Hello, and welcome. In this session, we will explore Azure Virtual Machine Scale Sets, a critical compute resource for running high-performance, scalable applications. We will break down exactly what they are, how auto-scaling works, and why they are essential for modern cloud architectures. Let's start by defining Azure Virtual Machine Scale Sets, or VMSS. Essentially, a scale set is a group of identical, load-balanced virtual machines. Unlike single VMs that you configure one by one, VMSS allows you to deploy and manage a fleet of VMs as a single logical unit. Because these instances are identical created from the same base OS image, you don't need to pre-provision or manually configure each one. This makes VMSS the preferred choice for building large-scale compute clusters and handling stateless workloads where redundancy is key. This mind map visualizes the core characteristics of a virtual machine scale set. At the center is the scale set itself. Branching out, we see it provides single-unit management for operational efficiency. It contains identical VMs that share the same operating system and configuration. It features integrated load balancing to distribute traffic, and fundamentally offers scalability, which can be triggered automatically or manually. The true power of VMSS lies in elasticity. Auto-scaling allows your infrastructure to breathe, expanding and contracting based on real-time demand. When your application load increases, perhaps due to a spike in user traffic, the scale set performs a scale-out action, adding new VM instances to handle the work. Conversely, when demand subsides, it performs a scale-in action, removing unnecessary instances. This ensures you only pay for the resources you actually need. You control these boundaries by setting minimum, maximum, and default capacity limits in your configuration. This diagram demonstrates the elasticity loop. On the top path, a load increase triggers a scale-out event, adding a VM and resulting in a higher instance count. On the bottom path, a load decrease triggers a scale-in event, removing a VM and returning the system to a lower instance count. This visualizes how the system dynamically balances performance against cost. How does the system know when to scale? It uses auto-scale profiles and rules. A profile is a container for your rules, and you can have different profiles for different contexts, such as a weekend profile versus a weekday profile. Inside these profiles are rules. A rule consists of a metric trigger like average CPU is greater than 75% and a scale action, such as increase instance count by 1. We also define a cool-down period. This prevents the system from oscillating rapidly. It waits for the metrics to stabilize after a change before scaling again. Here we see the relationship between profiles and rules using a class diagram. The autoscale profile class sets the broad context, like the profile name and overall capacity limits. It contains multiple scale rule objects. Each rule details the specific logic, the metric trigger, like CPU usage, the scale action to take, and the mandatory cooldown period. Networking is integral to VMSS. When you deploy a scale set, it typically integrates seamlessly with an Azure load balancer or application gateway. The load balancer's job is to distribute incoming traffic evenly across all the healthy VM instances in the set. You don't need to manually add each new VM to the balancer. The scale set handles this registration automatically. All instances reside within a specific virtual network subnet, ensuring secure internal communication, while the load balancer manages the public-facing traffic. This flowchart shows the flow of traffic. The internet connects to the Azure load balancer at the top. The load balancer then distributes that traffic down to 3 distinct VM instances: VM1, VM2, and VM3. These instances are grouped inside a VNet subnet, illustrating how the networking layer abstracts the individual VMs from the external user. To ensure your application stays online, VMSS leverages availability zones. You can configure your scale set to spread instances across multiple zones, physically separate data centers within a region. This provides zonal resiliency. If one data center goes down due to power or cooling issues, instances in the other zones continue to operate. Even within a single zone, VMs are split across fault domains, meaning they don't share the same power source or network switch. This architecture creates a robust shield against hardware failures. This block diagram visualizes zonal distribution. Inside the main region container, we have 3 separate columns representing Zone 1, Zone 2, and Zone 3. Each zone contains a VM instance, VMA, VMB, VMC. This clearly shows that the physical infrastructure for each VM is isolated, minimizing the risk of a single point of failure taking down the entire application. You have several options for deploying VMSS. You can use the graphical Azure portal for quick setups, or use command line tools like Azure CLI and PowerShell for scripting. However, for production environments, Azure Resource Manager, ARM, templates are preferred. ARM templates allow you to define complex autoscale rules and configurations in code, making your infrastructure repeatable. Managing updates is also streamlined. You simply update the model with a new OS image, and the scale set orchestrates the rollout to all instances. This sequence diagram outlines the deployment process. The user defines the configuration in an ARM template. They then submit this template to the Azure Resource Manager. The Resource Manager instructs the VMSS service to provision the instances. Once complete, the VMSS reports success back to the manager, which confirms to the user that the infrastructure is ready. In summary, Azure Virtual Machine Scale Sets are the backbone of scalable cloud computing. They are the perfect solution for big compute tasks like big data processing or simulations. They also serve as the underlying infrastructure for container orchestration platforms like Azure Kubernetes Service Acts. For standard web applications, they provide the elasticity needed to handle traffic spikes without manual intervention. By automating management and optimizing resource usage, VMSS delivers both high availability and cost efficiency. We conclude with a timeline view of use cases. Web apps benefit from stateless frontends and auto-scaling. Big data leverages VMSS for batch processing and high-performance computing. Finally, containers rely on VMSS as the node pools for Azure Kubernetes Service, powering modern microservices architectures.